Okay. Is it okay right now?
Yeah.
Yeah, it's fine.
Yeah. So
Good.
today we are going to do expressions and arithmetic in Python. This is just using Python as a calculator. I can say that using Python to perform calculations for most of the part, as you will see. So we start with what is an expressions. They are divided into two: simple expressions and complex expressions. Simple expressions is like a literal value like 46 and a variable like x are examples of simple expressions. Like we can say x is equals to 46. That is a simple expression. We will see the practical side of this after dealing the theoretical side of it. Complex expressions are obtained when values and variables are combined using an operator as shown below. E.g., you say x is equals to 6 and y is equals to 10, and then you say z is equals to x plus y. X plus z will be 16. That is a complex expression when you are using an operator to perform an operation. What is obtained is a complex expression, the whole of it. Okay. So expressions can be, these are examples of expression: x plus y, x added to y if x and y are numbers. X plus y, x concatenated to y if x and y are strings. For example, if x is 6 and y is 10, that is adding. If x is my and y is my, x is my and y is house. When you add them, you will get my house. X minus y, x taken away from y if x and y are numbers. X times y, x times to y if x and y are numbers. X concatenated with itself, y times if x is a string and y is an integer. For example, x is my and y is 2. What you will get is my. And then y concatenated with itself if x times if y is a string and x is an integer. For example, y is my and x is 2. It will be my. Okay. Up to there, have we gotten the concept of expressions before we go on?
Yeah.
Okay, let's continue. X divided by y, x divided by y if x and y are numbers. I want you to notice something. The minus and the divide does not have strings, they just have numbers. You cannot say my minus you, that will be wrong. You can't get an answer from that. But if it is my and house, you can concatenate them, but you can't subtract a house from my. That will be wrong. That is why minus does not have strings. Also, that is why divide does not have strings, because you can't divide by house. It does not make sense. Okay, x divided by y if x and y are numbers. And then I want you to notice there is this sign here that has two divide symbols. Law of x divided by y if x and y are numbers. This is just a division, but this one is an integer division. When you do division, it will give you a float as an answer. But now when you want to get an integer as an answer, you use this type of divide, this divide that has two divide symbols. That is the type of divide you will use. And then there is x modulus y, the remainder of x divided by y if x and y are numbers. If you want to get the remainder, for example, you have 5 divided by 2. You want to get the remainder of that, you use this percentage sign, which is called modulus. And then there is x and then 2 times signs and then y. That is x raised to power y if x and y are numbers. This is, for example, you have 2 and then you have 2 star signs and then y. This is 2 power 2. What do you get? Yes. The percentage operator is the modulus or the remainder operator. As we have said, the operator that has 2 division signs is called the integer division. It gives you an integer as an answer when you divide. And then all these operators are classified as binary operators because they operate on 2 operands. These operators are binary operators because you must have 2 operands to operate. You can't just have x times nothing. You must have a second number for you to operate. If you have x times nothing, you will get an error. In the statement x is equals to y plus z, on the right side of the assignment operator is the addition expression y plus z. The 2 operands of the plus operator are y and z. In short, this just explains this statement of binary operators, because as you can see here, the plus sign shows that y and z are added together so that we get x. Up to there, are we together? Is there anyone with a question before we continue? If you have a question, please raise it. Okay, let's continue. 2 operators, plus and minus, can be used as unary operators. Unary operators means that you can have -2, -4, -5. You can have a negative number and a positive number. That is what unary operators mean. Simply, it just shows the state of the number. You don't have to perform a calculation with it. For example, -5, it shows that that number is a negative number. Unary operators has only one operand, that is -7. It has only one. It cannot be -7. The unary operator expects a single numerical expression immediately to its right. It computes the additive inverse of its operands. Okay, this just says that it expects a number after the negative. For example, -5. It expects the number after the negative, or +5. It expects the number after the positive. You cannot just have positive nothing. There must be a number following the positive. If the operand is positive, the result in a negative value is of the same magnitude. For example, if you add positive plus negative, it depends with which number is bigger. For example, +5 plus -2, you will get +3. Or if you have -5 plus +2, you will get -3. So it depends with the magnitude. For example, but if you have +5 times -3, the answer will be -3. I hope you know these operations, positive plus negative operations. They are just the same. How you apply them in mathematics is the same way you apply them in Python. They do not change. If the operand is negative, the result is a positive value of the same magnitude. 0 is unaffected, as shown below. X, Y, Z, 4 minus 5, 0. If x is equals to -x, that will be x is equals to -4. Y is equals to -y. So minus times minus will be, minus times minus will be addition. So that will be 5. And then -0 doesn't have any value, so you cannot have -0. 0 does not add any value, so it just remains like that. It can be positive, it can be negative, but it doesn't add any value. So it's just like that. The unary plus operator is present for completeness when applied to a numeric value, variable, or expression. The resulting value is no different from the original value of its operand. This just talks about the operator. Unary plus operator is present only for completeness. Unary plus operator, sorry, I have understood. So this plus here, you can choose to write, like here 5, you can choose to write plus 5 or 5. It doesn't make any difference. It's just like the way we write numbers, 1, 2, 3, 4, 5. We all know those are positives. If we write plus 1, plus 2, plus 3, plus 4, plus 5, all the numbers will still be the same. It does not make any difference. What makes a difference is when we have a negative operand in front of the number, like here. This shows that the number is negative. But when we see a number like 4 as written here, it shows that that number is positive. We automatically know that the number is positive. Omitting the unary operator from the following statement, x is equals to plus y, does not change its behavior. So when you omit the plus, like here, it doesn't mean that now this 4 is negative. No, it's still positive. It's just that you have omitted the positive sign. All arithmetic operators are subject to limitation of the data types in which they operate. So arithmetic operators can be affected by the data types. For example, if you have a float and you multiply by an integer, you will get a float. For example, division, the normal division, not the integer division, the normal division gives you a float. So that shows the operators are subject to the data types of the numbers which they operate. For example, the expression 2.0 power 10,000 will not evaluate to the correct answer, since the correct answer falls outside the range of the floating point values. So if you do this, you won't get a correct answer. It will give you an answer, but the answer will fall outside the range of floating point values. The division operator applied to two integers produces a floating point result. As I have said, if you use the normal division, even if you use an integer, it will still give you a float. We will see when we go to the practical side of this. Okay, so now here is an example. As you can see, 10 divided by 3. This is an integer and this is an integer. It gives you 3.3335. This is a float. But when you do 10, 2 division signs divide by 3, it just gives you 3. Another one is the modulus operation. As you can see, 10 modulus 3. It gives you the remainder of that operation. 10 divided by 3, it will be 3 remainder 1. So it gives you the remainder of 1 here. The modulus operator is more useful than it may first appear. It can be used to convert a given number of seconds to hours, minutes, a given number of seconds to hours, minutes, and seconds. Yeah. Oh, yes. It can be used, for example, you are told to convert 10,600 seconds to hours and minutes and seconds. The modulus operator can be used to do that. Floating point arithmetic always produces a floating point result. This means that no matter where you see a floating point result, for example, if it is a floating point added to an integer, you will always get a floating point. If it is a floating point divided by an integer, you will always get a floating point. If it is a floating point multiplied by an integer, the answer will always give you a floating point. If it is a floating point subtracted from an integer, or the integer is subtracted from the floating point, the answer will always be a floating point. Floating point numbers are not real numbers, so the result of 3.1 divided by 3.0 cannot be represented exactly without a finite precision. This just means that floating point numbers are not real numbers. Okay, it just means that floating points are decimals, so the results cannot be represented exactly without finite precision. As we all know that 1/3, you will get a very long, a recurrent number. It is called a recurrent number. You will get a very long number. Okay, the program below gives x as this very long number instead of 0.0. As you can see, this is 1.0, and then z is 1/3. So it is y minus z minus z minus z. You take y, this is 1 minus 1/3 minus 1/3 minus 1/3, and then you print x. You will get this answer. Now, this is what I mean by when I said this statement. It will give you a very long number of, it will give you an answer that has a very long number of decimal places, like here.
Excuse me, from Yvonne.
Yes.
What is this bar here?
Where?
This bar after. Is it supposed to be there or?
Yeah, no, this is just a cursor. Sorry, this is a cursor.
Oh, okay.
Yes,
I thought
yes.
like it's supposed to be there.
Yeah, it's a cursor. Okay, I think up to there we should do a little bit of practicals, and then we'll get back to this. So I'll just stop sharing my screen first as I open my Jupyter Notebook. So I hope you can see my screen.
Yes, I'm seeing it.
So we can try like y is equals to, my caps lock is on, y is equals to 10, x is equals to 11, and then z is equals to y plus x. Then we print z, then we run this. 21. As you can see, this is addition. Let's try division. Y is equals to, so that we prove that it gives you an integer 100. X is equals to 10. Z is equals to y divided by x. Print z. As you can see, this is an integer, this is an integer, but instead of giving you an integer, it gives you a float. This is what we meant. We can try multiplication. Y is equals to 100. X is equals to 10. Z is equals to x times y. Print z. Here it gives you an integer. An integer multiplied by an integer gives you an integer. Okay. Is my screen clear? Okay.
Yes,
So
it is.
Yeah, it is not
So,
that bad.
so what it means is that, I mean, in a division, the
yes,
result will always be a float.
yes. But we can have an integer division where if you want to get an integer as a result, let's do an integer division. It's y is equals to 100, x is equals to 10, z is equals to y, and then two division signs, divide by x. Print.
Okay. I get you. So you got to use two division
Huh?
signs.
Yes, sorry. Yes, I have written the word print wrong. Yes, as you can see,
Okay.
yeah.
Oh,
So
all
if
right.
you use one division sign, you get a float. If you use two division signs, you get an integer.
Yes. So this two division signs is called an integer division.
Okay, one division sign is a float division.
Yes, one division sign is a float division, always a float division. It doesn't matter it doesn't matter if one number is a float or both numbers are integers. As you can see here, both numbers are integers, but it has still given us a float, right?
Yeah.
But yes, now this one, two division signs, it's a special division actually. And you will hear people call it an integer division. This is just what they mean. You just get an integer.
So there is an integer division, there is a modular, and
yes,
then there's a float
modular
division.
Okay, modular gives you the remainder. Let us see the modulus. Yes, like y is equals to 10. X is equals to 3. Z is equals to 10 modulus 3. Print Z.
It's going to give us 1.
Yes, now this is the remainder. The modulus gives you the remainder.
Okay.
Okay.
Mhm.
Let's try subtraction. We have not tried subtraction. 100, sorry. X is equals to 9. Y is equals to, let's say, 5. Then Z is equals to X minus Y. Print Z. 4. This is subtraction of integers. First, we are dealing with integers, then we go and deal with floats, then we'll deal with float and integer and see what we will be getting, right?
Okay.
Okay. Okay, let's continue. So, okay, so we have done addition, division, multiplication, integer division, modular subtraction. I think we have done every operation. You have done every operation using the integers. Now let's go to the floats. Okay, let's try using strings and see. X is equals to hello. Y is equals to world. Z is equals to X plus Y.
It's concatenation.
Yes, Z. Let's concatenate. Hello world. As you can see, we can try the subtraction and see what we will get. Like the way I was telling you, it won't work. Let's see if it really won't work or I was wrong. Hello. Then Y is equals to world. Z is equals to X minus Y. Print Z. Let's see. You can see You can't
Mhm.
subtract a string from a string, just like the way I was telling you. It is impossible. Let's try division and see if I was wrong or correct. Yes, as you can see, as I was telling you, you can't divide a string by a string. You can't also use the modulus operator using on a string. Yes.
Okay.
So, but you can definitely add. You can definitely add this. It will print hello world. Yeah, I didn't. Let me space this just a bit. Yeah. But I want you to note something.
I have a question. I saw
Yes.
you put space after hello and there was space in the hello world. If you put space below W down there, I mean before W, can it not give you the same space? Try. Yeah.
Yes.
Or is it the same?
Yeah.
Also you can put it either at the end of the first one or before the second one.
Yes.
Good.
Also, let's try this. We have seen that you can multiply a string with a number, but you can't multiply a string with a string. Let's see if you can. Yes, you can't multiply a string with a string, but you can multiply a string with a number. For example, let's say y is 5. You'll get hello, 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 hello 5 times. You can multiply a string with a number, but you can't multiply a string with a string. Okay?
Okay.
Let's continue. Yes, we have that. Now let's go to floats.
So now can you multiply a number with a string, the number first and the string second?
Yes, you can. It won't be any different. Let's try. You will see. 5 and then hello.
Or it's gonna be the same. Oh,
It's just like 5 plus 6, 6 plus 5. You will still get the same answer. So it's the same way. It's applied the same way here. You can multiply 5 times hello or hello times 5. You will still get the same answer. Okay?
okay.
Okay, let's go on. You can, okay, let's go to the float operations now. Y will be like 3.0, x is equals to 4.0. And then z is equals to x plus y. Print z. You can see it has given us a float here. Let's do an integer and a float and we see what it will give us. Y is equals to 3. X is equals to 4, okay, 4.0. Z is equals to X plus Y. Print Z. As you can see, as I was telling you, if you add a string, if you add a float with an integer, you will get a float. And here is the float. Okay, let's do subtraction. For example, you have y is equals to 8.0, x is equals to 4.0, z is equals to x, okay, y minus x. Print z. A float, as you can see. We can also do multiplication. Okay, we can do an integer minus a float. We see what we will get. Y is equals to 8.0. X is equals to 4.0. Print.
I think both are floats.
Oh, sorry. I didn't even notice. Yes, thank you for that correction. I'm sorry, I didn't notice. Z is equals to y minus x. Print Z. It has given us a float again. So when you take an integer plus a float, you will get a float. When you take an integer minus a float, the answer will be a float. Okay, let's go to multiplication. Sorry?
What about an integer minus an integer? Do
You
you
get
get
an integer. See, we did
with
it.
an integer? Okay.
Yes, we did it around here. Where is it?
Okay.
Yeah.
Okay.
We got an integer.
Okay. Okay. Fine.
Yes. Yes. I would also encourage you to open your Jupyter notebooks and go with me. As I do, you also do, and then you see if you're getting the same thing. That way we will all be doing practicals. Okay? Please open your Jupyter notebooks and then we do it step by step together. As you are doing it, I am also doing it. And then we are also getting the practice that we need. Please, I will give you.
I don't know if it
Okay.
will I'll try.
Okay.
I don't know if I have to split the screens or
Yeah, I don't know how to, I'm not able to minimize this screen as well.
Okay.
I
Okay.
can do it. I cannot do it because it's your screen though.
Okay. Okay. Fine.
Yeah,
So
right.
then I will just send you my notebook after the class, and then you can check what I have done and also try to do it. Okay. But make sure
Okay.
you practice. Practice makes perfect, and there is no way you will learn Python without practicing. Even if you see someone do it, you should also go and practice. So
Yeah.
let's do multiplication.
Okay, I got my Jupyter notebook, but it's taken the whole screen. Let me see.
Okay.
Let me see. Oh, okay. I have the terminal here, and I need to cut the terminal.
How did you do that?
No,
You just if you have Anaconda installed in a computer.
Yeah, I do.
Okay, just click on that Windows sign, and then you type.
My
then you-
problem is that Yvonne's screen is occupying the whole of my screen. I'm not able to minimize her screen.
Oh, I see. I think Yvonne will just go with your practicals.
yes, and then I will share my notebook after this. I
Okay.
will, and then you will run it, and also you will try to do your own practicals from my notebook and see how it goes. Okay?
That's fine.
Okay. Let's do a float multiplication. So y is equals to 4.0, x is equals to 4.0, z is equals to x times y. Print z. As you can see, it has given us a float. A float times a float, it is a float. Let's also do an integer times a float. We see what we will get. Y is equals to 4, x is equals to 4.0. Z is equals to x times y. Print z. As you can see, it has given us a float also. So a float times an integer will be a float. Okay, let's move on to division. Let's do division of a float divided by a float. Y is equals to 100.0. X is equals to 10.0. Z is equals to Y divide by X, sorry. Y divide by X. Print Z. You can see it has given us a float. Let's try an integer and a float and we see what we will get. Y is equals to 1000. X is equals to 10.0. Z is equals to Y divided by X. Print Z. You can see an integer divided by a float is a float. Let's see if we do the integer division, it will give us an integer. It still gives us a float. Have you seen?
Yes,
So
I'm
this
saying integer division is still a float. Why?
yes. So no, integer division only works on integers. If you have one number as a float, it will still give you a float. It will behave like a normal division. It will
Okay.
behave like a normal division, yeah. But if both of these were integers, it will give us an integer. But since one of these is a float, behaves
Okay.
like a normal division. Yes.
All right.
So let's try a modulus. I have really never tried a modulus on an integer, on a float. Let's see how it will behave. 1000.0 y is equals to 9.0. Z is equals to x modulus y. Print Z 1.0. It also gives us a float.
A
Let's
float.
try, yes. Okay, let's try an integer and a
Yvonne,
float.
Yvonne,
Yes.
please excuse me a little bit. It's it's like I got lost somewhere.
Yeah,
Now,
where
can
are
you please scroll up? I wanna see these divisions. So
the
no,
division?
I wanna see the division. Yeah. So this is 10.0. So if we divide an integer and an integer, we still get a float or an integer. Sorry, I got lost.
So let
An
me add a
integer.
cell here. An integer a normal division, when doing an integer, we will get a float. For example, y is
A
equals to
float. Always.
always. Maybe now you use the integer division. That is a special type of division that gives you an integer. But if you
Now,
use
can you
the
use
normal-
just a float?
Pardon?
100 divided by 5. Can you
Yes.
use just a float division like 100 divided by 5? Just that.
Okay, z is equals to y divided by x. Print z.
That's going to give you an integer.
No, it will give you a float.
A
Oh,
float.
a float. Yeah, it's going to
Yes,
give you a
yes.
float. Yeah, it's a float division. Yeah.
Yeah.
Okay.
Yeah.
Wanted to get that clear. So
But
whenever
now-
we're using the normal division, always the answer is a float, no
Yeah.
matter the inputs.
Yes.
Yes.
But now if you want now to get an integer as an answer, if you don't want to get a float, because there is sometimes when you do projects, you will find that you don't want a float, you want an integer. That is when now you use this special type of division known as the integer division. Then it will give you an integer instead of a float. Have you understood?
Yes.
Yeah.
Okay. Okay. Let's continue. We were here in the modulus. As you can see, the modulus, it is 1.0. Okay, it is a float. We can
Now,
do,
no,
yes.
that one is kind of confusing because I thought that you should only give the remainder, which shows there as an integer, but it's giving us a remainder, which is also a float again.
Yes, so
The modular division.
But the remainder is 1.
yes, but it is one of a float. It is like you have a snake and a snake. It will give you a baby snake. Even though the snake is small, it is still a snake. It is the same thing with here. it is a float and a
Oh.
float. It will give you a baby float, even though it is, and it looks like a number, it is still a float.
Still a float. Okay.
Yes. Have you understood?
Yeah, I get
Or
it.
it is, yes. So
Okay.
I want to, the float data type is like a very big data type. It's like it takes, when you have a float and an integer, just know the float will take over the integer. The answer you get will most likely be a float, no matter the operation. Like we have tried division, multiplication, addition, subtraction. You have seen that every time there is a float, the answer you get is still a float.
Okay.
Yeah. So we have not done the power. Sorry, let us do y. Let us do the power for integer, then the float, and we see. Okay, first let us finish this modulus. Let us do a modulus with an integer and a float. We see how it turns out. Y is 1,000, x is 9.0. Then z is equals to y modulus x. Print
Now it's going to be a float.
Yes. Yes, as you can see, a float, wherever there is a float, just know the answer you are going to guess, it will most probably be a float. So let's go to the power. We have not done that one. So we have y equals to 4. X is equals to 2. Z is equals to y power
Oh,
2 power x.
okay.
Yeah, print
Z.
16. So this is just 4 squared. This is y power 2. This is 4 power 2. So
Must
it will
we
be-
use spaces
No.
before we write the?
No, I'm
the-
just doing that for it to be clear. It's not a must. I'm just
Okay, so it
writing
doesn't
for-
make, I mean, it doesn't make a difference.
Yes, I'm just writing it for
Okay.
it to be more clear and it to be well
Gotcha.
arranged.
Oh, gotcha.
Yes. It's not, the space doesn't affect anything. I can remove it, I
Okay.
can add it, yes.
Okay.
So let's do a float. We see what we will get. But I want you to tell me, what do you think we will get when we do the float power?
Float.
You're going to get a float.
Yes. Y is equals to 4.0. X is equals to 2.0. As you can see here, let me not use space here, and here I use space. And then we see what will be my answer. Y power yes, we have gotten a float. As you can see, spaces don't affect anything. Here there is no space. Here there is space. But it has still given me the answer 16.0. So spaces also, it just makes your work look more neat and clean.
Yeah.
Oh, good.
So let us do an integer and a float. We see what we will get. Equals to 4. X is equals to 2.0. Z is equals to y power x. Print Z. Yes, it has given us a float.
Float.
Yes.
Okay.
So these are operations in Python. As you can see, you can use Python as a calculator. We have been using Python as a calculator from when we have started, and these are expressions like this. This is a complex expression, as we have seen, and this is a simple expression. As we have seen in the start of the class, we read that slide which was talking about expressions, and this was the simple expression and this was the complex expression. Up to there, is there anyone who has a question? If you have a question, please raise it before we move on.
I'm sorry about that, simple and complex. I didn't read it well, but to me, they both look simple to me. I don't know.
Yeah, okay. Yeah, the complex expression is an expression that has an operand in between. Yes. Operator.
Okay.
Yes, sorry, an operator in between the two operands, but
Variables.
here variables.
They call
Those
Okay.
words confuse me. Okay, this is an operator. Okay, let me put it in simple words. And a complex expression is the one which has a plus or a minus or a modulus or a division sign in between the two assigned variables like y and x. And a simple expression is just y is equals to 10. It has been, the variable y has been assigned a value 10. That is a simple expression. Okay, now
Okay.
is it clear?
Yeah, I get it now. Thank
Yes.
you.
So we have done most of that. Let us continue. Let me share my slide. Let me stop sharing and share my screen again so that we continue with the slides.
We have Rose Depra.
Yes, that is
Rose, welcome.
yes. So we will continue. You can you see my screen?
Yeah.
Yeah, I can see it, yeah.
Okay. So a programmer may break up a very long line of over 2 or more lines by using the backslash symbol at the end of an incomplete line. When the interpreter is processing a line at the end with a backslash symbol, it automatically joins the line that follows. The interpreter thus sees a very long but complete Python statement. For example, this here. If you have a very long line here, this, for example, this one is 0 is equals to 1 minus 1/10 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 minus 1/10. And then now, because this line is very long and you don't want to have a long line there, you can just use this backslash to tell the compiler that this line that follows is still a continuation of the line above. Yes, it's like a paragraph. You see the way you read a paragraph, you don't say that when you see a paragraph, you read it all completely. You don't say that this is one page, this is another page, this is another page, but you read it completely as one paragraph. This is the same way a compiler will read this statement. It won't say that this is one statement, this is another statement, this is another statement. It will just read the whole thing as one statement. Or like when you use a comma to separate your statements, you won't say that the first statement is ending at the comma. No, you will say the first statement ends at a full stop. So this backslash acts like a comma. This backslash acts like a comma when it comes to the compiler. So the compiler will just see this as one whole line. Are we clear?
Somehow.
Have you understood? Sorry?
Not really. You can repeat that again.
Okay, so here the compiler sees this as one line. Sorry. Here the compiler sees this as one line. Okay, let me Here, the compiler sees this as one line, even though there is a
Oh, so
backslash.
what you're saying is that everything there, or those 3 lines, those 4 lines, sorry, the compiler sees all of them as one line.
Yes, yes. It's just that you don't want to write it as one line. So instead of writing it as one line, because it will be very, very long. If you take this, you try to write this as one line, it will be a very long line. So instead of writing it as one line, you can put backslashes. Have you understood?
Okay, yeah.
Yeah,
Yes.
yeah. Now, if I might recall, if that backslash, sorry, if the backslash and n was in between a sentence, that means starting a new line.
Yes. That is,
Oh.
yes.
Okay.
Yes.
So without n, it's like telling the compiler that is one line, everything is one line.
Yes. Yes. Yes.
All right.
Okay. When an operator has mixed operands, one operand an integer and the other operand a float point number, the operator treats the integer operand as a floating point number and performs the floating point arithmetic. This is just what we have been doing, the floating point operation 7.5 plus 3.5. As you can see, it will give you a floating point. This means that x plus y is a floating point expression and the assignment will make sum a floating point variable. Okay. As you can see, this is just floating point operations that we have done. Right. Operator precedence. This is, do you remember body mass? Was it body mass or body mass? It was a
Yeah,
Body
bod
mass.
maths.
Yeah.
Bod maths.
Yes. Now this is what we do here. Operator precedence determines which operator is executed first in an expression. In 6 minus 8 times 4, the precedence of multiplication is higher than subtraction. Hence, 8 times 4 is evaluated first. So if you have 6 minus 8 times 4, you will do the compiler will do the multiplication first, and then it will do the subtraction next. The multiplicative operators are multiplication, division, the integer division, and modulus have equal precedence with each other, and the additive operators binary and negative, the additive operators binary positive and negative have equal precedence with each other. That means that wherever there is a division and a subtraction, the compiler will perform the division first. Wherever there is an integer division and a subtraction or an addition, the compiler will do the division, the integer division first. If you have a modulus and a subtraction, the compiler will do the modulus first. All these operators, the division, the multiplication, the integer division, and the modulus carry the same weight when compared to the subtraction and addition operators. Have you understood?
Now, Yvonne, there was some acronym that you gave us before. I think you called it BIDMAS, and there's another one also, PEDMAS. There's BODMAS, which is the regular one.
Yes,
And
that
then I
is.
saw there was BIDMAS, and then there was PEDMAS. I don't know,
Wow.
BIDMAS was like British and PEDMAS was US. And they also signified the sequence of operations.
Yes.
So
When did you
I'm a
learn
little
that?
mixed up.
No. That is in mathematics.
Oh, that's in mathematics.
Yes. I was just using that to introduce this.
Okay.
But it can also be applied here. But I will tell you that that mostly applies in mathematics. Okay.
Oh, that applies in mathematics.
Yes, mostly.
So this one is still the BODMAS.
Yes. Yes, this one is still the body mass. As you can see, the multiplication, the division, the integer division, and the modulus comes before the binary addition and subtraction. You can still apply body mass here, but sometimes, sorry, you are trying to speak.
No, that's not me.
Okay, but
Yeah.
sometimes it doesn't really follow body mass, but mostly that the body mass is just to introduce this concept. I can say that.
Oh,
But
okay.
yes,
Okay.
when we have brackets, the brackets will come first.
Yes.
Yes. When we
All
have
right.
multiplication, the multiplication will be performed first. But if we have a brackets and multiplication, the brackets will be performed first and then the multiplication will follow suit. Okay?
Okay.
This is, but you know, this is not something that you will just get directly. It is something that you must practice and study on it, and then you will get it. Okay?
Okay.
Yes.
Thank you.
So operator associativity determines the direction in which two operators of the same precedence are executed. Okay. In the expression 6 minus 4 minus 2, the two operators are the same, so they have equal precedence. 6 minus 4 is performed first, hence it is left associative. So for example, if you have 6 minus 4 minus 2, all of these are negative, right?
Yes.
So to perform this one, you will move from left to right. You will do 6 minus 4 and get 2, and then 2 minus 2, I get 0. As in the case of precedence, parentheses can be used to override the natural associativity within an expression. See the example below, minus 5 minus 8. This will be minus 13. So here it will add instead of subtract, because it will be like minus 5 minus 8, you will obviously get minus 13. But if you put here parentheses, it will be minus 5 minus 8. It will now make sense, like 5 minus 8 is equals to 3. And then is equals to minus 3, sorry. And then minus 3 times minus, because parenthesis introduces multiplication, as we have seen in mathematics. So minus 3 times minus, negative times negative is positive. So it will be 3. The table below shows precedence and associativity rules for some Python operators. Unary is plus and minus. As we have seen, the unary, it can be plus 4 or minus 4, plus 5 or minus 5. Like here, this is a unary operand of plus 3, and this is a unary operand of minus 13. And then binary operand is multiplication, division, and modulus. It does from left to right. The binary operand of addition and subtraction, it does calculations from left to right. But the equal signs, like the way you have seen, z is equals to x plus y, it does from right to left. Like the left side is the z, and the right side is y plus x. So it will start with the right side, y plus x, and then assign the answer of y plus x to z. Is this clear? Are we clear?
Not quite. I see the silence.
Where
You may want to repeat the second part below arity operators and associativity.
below here?
Yeah, there.
So, okay, operators. we can say unary. Unary is like this, -13. That is a unary operator. It is just a number assigned to a negative sign to show the state of the number. It is negative. This is +3. So it shows the state of the number, which is the number is positive. Have you understood up to there?
Yes.
Okay, and then binary operators. For example, here, 6 - 4 - 2. This is a binary operator, right?
Yes.
So calculations will be performed from the left to the right, as we have said. It will be 6 - 4 - 2. Then there is binary operators like the way we were doing x plus y. Okay, 10 plus 4. It will be done, the calculations will be done from the left to the right, and the answer will be 14. Have you understood the binary operators?
Yes, now I get it.
Yes. And then now there is the equal sign. The way we had z is equals to x plus y. Now, when we have z is equals to x plus y, we will perform the x plus y first. And then after x plus y, we will assign the answer of the x plus y to the z. So the operations will move from right to left. If e.g. z is equals to 10 plus 9, we will perform 10 plus 9 and get 19, and then the value 19 will be assigned to z. Have we understood?
Yeah.
Yep.
Yeah.
Okay. So comments. Let's do comments and then we can stop there. So, sorry, just 1 minute. Okay, so comments. Comments are remarks that explain the purpose of a section of code or why the programmer chose to write a section of code the way they did. We can just say comments explain more about the code. E.g., the statement 10 integer division 3 gives the integer part and truncates the fraction part. This just says that 10 divided by 3 gives you an integer. Like here, any text contained within comments is ignored by the Python interpreter. So when you write comments, they won't be executed. The different programming languages have different ways of writing comments. And in Python, we use the hash sign before the statement which we want to use it as a comment. The symbol hash begins a comment in a source code. The comment is in effect until the end of the line of the code. For example, here hash the statement 10, this one here. When you run, the Python interpreter won't execute this because it is a comment. You may also append a short comment at the end of the statement. The 10 divided by 3 gives a floating point number. You see, when you run this, it will still give you an answer. It will not run the comment. Have you understood up to there before we go and practice comments?
Yeah, I have a question, because at times we see comments and then below the comment, there is some operations to be done, but within the same cell.
Yes.
So will
No.
Python still ignore
Yes.
that comment and perform the operation?
Yes, let us go and do and see. Let us go and practice and see. Okay, let me stop sharing and then I share my Jupyter notebook, please.
Okay.
So let us try what you have said, right? Here, let us do it here. Hash. This is a power operation. As you can see, it has, yes, it doesn't matter where you put the comment.
Permutation, but
it still runs. Even if I put it here, it still runs.
Okay, okay,
Yes.
good.
If I put it here, still runs. So the Python interpreter doesn't read anything. If I add hash here, I have commented this, and when I run this, it will give me an error because it will not read. It will not read this, the Y.
Yeah.
Can I run it? You see?
Yeah, it's gonna be an error.
Okay. Why is it
It-
running? Oh, because, okay, let me change this to C. And it is running because I have defined Y also here. So it is picking this number. As you can see,
Okay.
it has not
Oh.
read the C. It has said
Oh.
that C is not defined, even though it is here, but Python has ignored it because it is a comment, okay?
So Python does not recognize comments?
Yes, it ignores
Yeah.
comments. Anything,
Okay.
yes. But
And
when,
anything that comes after the hashtag is a comment.
yes,
Yes.
yes. So if okay, let's try with, let me do M, and then I do a hashtag. Sorry, M. As you can see, Python has not read that I have changed this value to M because I have added the hash. But if I remove it, it reads it. Okay?
Okay.
So that was today's class, and I request that please put on your cameras so that I take a screenshot of the attendance, and then after that we can go to break and come back for Excel. I think the lecturer will be in today. Okay.
Sure. Thank you so much, Yvonne. That was awesome.
Okay. Thank you. Okay, so let me also, can you see me?
Oh,
Okay.
yes, I can see you. Today we saw you finally.
Okay.
You've been
So let
hiding
me-
from us.
Yeah. Oh my God. Where did I go?
we can't
Yeah.
see you. We can just see a padlock.
Wait a
Can you
minute.
see? Ruth, where are you? You have a padlock.
Yes. Okay, let me take a screenshot of the attendance.
Sure.
I don't know why I'm not seeing here.
Maybe, I don't know, maybe you have a problem. You should check your Zoom. Okay,
Mm,
so thank you for that. You can now switch them off. I have already taken the attendance. Okay, thank you for attending the class. The next class will be starting at 3. So go, relax, and meditate on what you have learned today
Oh.
as I prepare to send the Jupyter notebook. Okay.
Thank you.
Okay, thank you, Yvonne.